Hello, my name is Ryan. Welcome back to another video. Today we're going to be talking about the internal resistance of a lithium polymer battery pack and its link to the C rating. So let's get started and understand exactly what the internal resistance means. So internal resistance is the electrical resistance that we see within each cell of the battery pack. When we take the resistance of each cell and we add it up, we get the total amount of resistance of the entire battery pack. Now, whenever we talk about internal resistance to a battery pack, this is something that resists the flow of electricity through the battery pack. And if we resist the flow of electricity, we are diminishing performance. So we're looking for the lowest amount of internal resistance in a setup, in a given setup. When we look at most chargers on the market today, they are fully capable of measuring the internal resistance either during a charge cycle or a discharge cycle. You have to have one of those computerized chargers in terms of most of those are the ones that measure these internal resistances. When we take those measurements, we have to make sure we're doing it consistently. So what I mean by that is if you are charging your battery pack or discharging your battery pack, use the same method every single time you are looking at those resistances. What I like to do is measure internal resistance when I'm charging a battery pack from a cold state. So from a room temperature state. I don't take my battery pack off of the plane or a car, whatever I'm using it in, and then immediately start charging it there. I'll get different values because the battery pack's not going to be at room temperature. It's not going to be at that consistent temperature. It's going to be at an elevated temperature, if anything. Now that we understand what internal resistance is, what is the significance of internal resistance? The internal resistance within a battery pack is a very good representation of the overall health of that particular battery pack. More so, if you go into detail of per cell, on a per cell basis, it is the overall condition of each individual cell within that battery pack. You can have a bad performing battery pack and it's only bad because of one particular cell in a battery pack. That is very possible. One of the things that we do have to understand that if you know the battery pack's internal resistance on a given day, the only way that you can understand its overall health is by using a baseline value. So in other words, when you go and get that brand new battery pack, one of the first things that you want to do is go ahead, throw it on that charger, get a good internal resistance value while you're charging it in that cold temperature state. Every single time you're charging it, record that value as long as you're doing it in the same conditions, and this will establish your baseline. This way, a year or two later, when you go and check the value of internal resistance on your battery pack, you will be able to compare up against that baseline that you established. If I tell you that your battery pack was at 9 milliohms, it really doesn't explain on a per cell basis if that is good or bad. Different battery packs will have different internal resistances when you consider the different parameters associated with them that we'll get into shortly here. The big point here is that a battery pack that is in good health does not really deviate from the original values that you recorded as a baseline. For example, if your baseline value is about 4.5 milliohm per cell and you go ahead and you measure it a year later, you may see 5 milliohm per cell. This is a very good representation that the battery pack did not deviate too far off of the original and it's in good condition. If you are seeing a difference in the battery pack's internal resistance where there's deviation between your baseline and your results today, this is a suggestion that the overall health of the battery pack has decreased. Now, what you'll see in terms of this decreased health of the battery pack is poorer performance within your given setup. If you're looking at a setup that is very amp hungry and definitely chews through the amps, this is where you're going to see a major voltage drop with a reduced amount of amp draw versus the time when you ended up running that application with a fresh battery pack, with a brand new battery pack, or that battery pack just maybe a couple years earlier. In addition to poor performance within your lithium polymer battery pack, you may also see a couple of these other parameters weaken. This is the temperature of the battery pack. The temperature is going to increase in the same given setup. This is because the internal resistance contributes to that heat. Anytime you resist the flow of the electricity, you're going to have heat build up within that battery pack. This is one way that you'll be able to also identify a weaker battery pack. The third item that you may also see when internal resistance of the battery pack increases is a decrease in the overall amount of capacity of the battery pack. If your battery pack is rated at 5,000 milliamp hour, you may only be seeing 4,500, 4,200 total within that battery pack with that difference in internal resistance. The way to confirm this is to take your battery pack down to that 20% level and then go ahead and charge it from 20% to 100%. You should then be at 80% charge of that battery pack. Now let's take a look at which parameters on the battery pack contribute to the internal resistance of that battery pack. This way we could actually be able to predict what type of internal resistance we can expect. So if we look at two parameters that contribute to the internal resistance of a battery pack, these two parameters are going to be the capacity of the battery pack and the C rating of the battery pack. Those are the two parameters that significantly contribute to that internal resistance. So as we have a larger battery pack, we will have a higher amount of current that we can discharge from that battery pack. Our internal resistance is going to decrease. Now, when we talk about the C rating, a higher C rating will also contribute to more power being able to be pulled from that battery pack, which in turn suggests that the internal resistance has to be down, has to be lower. So as these two values, capacity and C rating, go up, the internal resistance of our battery pack goes down. This is exactly what allows us to pull more power from that battery pack. Now, how does capacity contribute to the internal resistance being lower or decreasing? Well, if you look at a bigger battery pack, allowing the battery pack to expand in cross-section or the distance in terms of length or width allows the battery pack chemistry to operate over a larger surface area. This is one way that we're able to decrease the amount of resistance. It's the same thing if you were to see us use a wire, let's say a 22 gauge wire that has a small cross-section versus an 8 gauge wire, for example. The internal resistance of the 8 gauge wire is going to be much lower than the 20-something gauge wire. This is because the cross-section of those two wires are different. One is higher, one is lower. Bigger cross-section, lower internal resistance. Now, when we talk about the C rating of the battery pack, this really refers to the chemistry within the cells itself. If we have a better chemical reaction occurring within the battery pack, one that provides a more significant role in terms of keeping that internal resistance down, that's where we're going to see the performance benefits. So when we're talking about C rating of the battery pack, that really goes and puts emphasis on the chemistry and what we're doing with the battery pack in that respect. When we're talking about capacity of the battery pack, we're allowing more energy to transfer through using a larger cross-section. These are two ways that you can look at how a battery pack is able to have a good amount of power being able to be pulled from it because it has lower internal resistance. Now, I hope you liked that video. Don't forget to hit that subscribe button and the like button if you do, and I'll see you in the next one. Thank you for watching.